Okay folks, today we're going to do a little demonstration video on measurement as it pertains to cylinder head repair. We've got several pieces that we're going to be using today during our demo. We'll be using a 1-inch mic, split ball gauge, which is a glorified telescoping gauge. It expands as you turn the knob. We're going to use two versions. We'll use a telescoping gauge and a 2-inch mic, a plain 6-inch steel ruler, which should be in your toolbox, a specialized mic for measuring a specific measurement on the cylinder head, and a dial indicator. All these components will be used for various measurements. We'll go into each individual measurements as we go. Alright, we'll have a little intermission here while I get everything set up. I brought out the cylinder head that we've had in other videos. We're going to continue on the path to healing this cylinder head. Okay, we're back. Now we're going to do valve installed height. This is an important measurement because this will determine how much spring tension is on the valve when the engine is running. We're worried about the closed tension, and it will affect open tension also. So some of the things that we can do this several different ways. We can use a special mic specifically designed for the purpose, or we can use a mic and a telescoping gauge. You have to use what you've got. We're going to give you a demonstration of both so that you have an idea how it's supposed to be done. You're going to need the valve from your rack, the retainer, and the two keepers in order to do this measurement. So we're going to plate the valve. We're going to place it in the guide. We'll start off with our specially designed mic. Place it in place and put our keepers back on. You're assembling it as if you were putting it together, only there's no valve spring. I'm going to pull up on it. I don't know if you can see it very well on the videotape, but what I'm going to do is turn this. It's a two-piece mic. I'm going to turn it around until it comes up taut against the valve, like so. Now the valve is being held closed with our specialized mic, and we can turn it around, and I'm going to make an attempt here to zoom in on the mic. Might be a little jittery, so just bear with me here. Yeah, that's pretty good, not too bad. Alright, so if you look at the mic is designed in such a way. Now, you'll notice that the retainer, this is a special case, the retainer is down into a recess on the tool. The manufacturer of the tool tells us that we have to remove 130 thousandths for that phenomenon when we see it. Okay? Now, this is a 1 to 2 inch mic, so everything starts off 1 inch, and if we look closely, and I got to get my head here a little bit closer, I got 760 thousandths, and maybe 58. So I got 1 inch, 758. Hopefully everybody sees how I got that number. Remember, you automatically add an inch, and then you direct read the mic. So that's what I've got. Now I've got to remove 130 from that. So if we make it easy math, say it's a 1 inch, 760. It would be 1 inch, 630. Nice and simple. Okay? Easy mic to use, not too terribly difficult. Now, if you don't have the special mic, now you have to do it the hard way. So we'll back this off. We'll push in on our keepers so we can pull them out. Remove our retainer. Now we have to put the retainer on and the keepers. Sometimes you get lucky with this. If you pull it tight against the taper on the keepers, they'll stay put for you. Next thing you got to do is take your telescoping mic, collapse it, pull up on the valve, place it in between. I usually like, there's two sizes of plunger here. There's a large and a small. A lot of times the large will work better on the bottom than on the top. Now I'm trying to do this, of course, with the camera right in tight, and you can barely see. If I can get my fat fingers out of the way, there we go. You can see what I've done. I've placed it between the retainer and this spring seat on the head. Now I'm going to pull it out. I have it now locked on the telescoping gauge. I'm going to zoom out so you can see better what I'm going to be doing here. All right, now I've got that measurement locked on our telescoping gauge. Now all I have to do is measure what we got here. One inch, 600. And 30. Okay, so the two mics do agree. So that is installed height. Remember, this is to keep the spring tension. Okay, to make sure that the engine runs at it will run at the specified RPMs, because the spring is also there to keep the engine from going into valve float. All right, that's our first measurement. We'll have a brief intermission while I get set up for the next measurement. All right, we're back again. We're going to do our next measurement is valve stem diameter. We're checking for wear over the length of the stem. We're going to also measure the valve for margin to make sure that there's enough material left there that we can actually grind the valve and put it back into service. So let's start off with our stem diameter. Pretty simple operation. You need a 1-inch mic. You're going to take the valve out of the rack. You're looking for the shiny portion, usually closest to the combustion chamber side. That's where you're going to find the most amount of wear. Take your micrometer, very simply place it over the top, and take a reading. Here I have 313 thousandths on this valve stem. Now some engines will give you a specification for what that diameter is supposed to be. Other manufacturers don't seem to be too concerned about it, so they don't give you any specification for it. If there's no spec, your job as a technician is to find the maximum amount of wear. It doesn't matter where it's at. So you're going to go through, you may measure this this valve stem several locations to see if there is any wear on this valve. It doesn't take that long to do it. It's only a couple of minutes. Once you have the first reading, it's either a go or no go gauge. Yes, this valve stem is the same all the way across the stem. So we don't have a spec for this engine, so we're going to say that it hasn't wore any in 100,000 miles. So it more than likely has a very good chrome finish on the stem. The next thing we're going to measure on the valve as we tore it apart is we're going to look at how much margin. In order to check the margin, we need a steel ruler, and we usually like to have something that goes down to 30/2 of an inch. This valve right now has a margin of about 3/64. So we're very, very close to being at discard with this valve. Now that gives me a red flag. When I get done grinding this valve, I have to check that margin again to make sure it is not too thin. Most manufacturers may or may not give you a spec for what should be left over for margin. If they don't give you a spec, we use a generic term, which is a 1/32 of an inch. So if you got a 32nd of an inch worth of margin, the valve is considered to be good to go back into service. So we'll grind it, we'll recheck it, then we'll grind the stem. That valve is ready for service. Okay? So that's all we have to do to measure a valve stem. The next thing we have to do is a guide. And there'll be a short intermission once again while I get set up for doing the valve guide. Okay, we're back. We're going to measure, one of our last measurements is going to be valve guide diameter. Okay, we're looking for wear again. Now when you look at the engine, it makes most sense that the most wear is going to be closest to the combustion chamber where the oil will vaporize when it gets into that hot combustion chamber. So we're looking at about 1/8 of an inch in from the combustion chamber side. Your guide should be cleaned before you start measuring it. As with any of these components, the valves that I've been showing you are cleaned with a wire wheel, a bench grinder with a wire wheel on it. In most cases, that's good enough for what purposes we're doing here at the College of DuPage. If you're out in the professional field, you may find where a lot of these valves are glass beaded to clean them so that they can be put back into service. Right now, we're more concerned about the guide. So there's two methods of checking the guide. We can use a micrometer and a split ball gauge. Okay. Split ball gauge is just for very small diameter holes. Makes it a little bit easier to measure things, okay, than trying to fool around with a really small telescoping gauge that more than likely is not going to be very accurate. So we're going to use a split ball gauge. Now we're going to have to take the split ball gauge. We got to keep in mind how the valve guide is going to wear. This happens to be an overhead cam head, but there's a cam follower on this engine. And the cam follower is working in, or has a rocker arm, I should say, with cam follower included with a hydraulic lash adjuster. And it rocks in this motion because the cam's through the center of this head on the other side. So we want to measure for wear in the same direction as the rocker arm is pivoting. Okay? So we want to measure that direction and about 1/8 of an inch in from the combustion chamber side. This split ball gauge, again, is nothing more than a telescoping gauge. So what we'll do is we'll go down in this hole. Again, the telescoping portion or the expanding portion of it will be parallel to the wear of the rocker arm motion, and we want just a slight amount of drag on that telescoping or split ball gauge. We'll pull it out, we'll take a measurement and see what we've got. I got 317 thousandths. Okay. Now that's one method of doing it. Now in order to find the wear, we'd have to take 317, subtract the valve stem diameter, which, as my memory serves me, is 313. So 17 from 13 be 4 thousandths. That's a little large for this intake. The spec on this engine is 1 thousandths to 3.5 thousandths on the intake valve. So we've got some wear in this guide. Okay, so that's one method of checking it. Now there's another method. Some folks, because this is an aluminum head, we can use a dial indicator, but because it's an aluminum head, we have to use a unit that can be used with aluminum. We can just simply place it on a solid place on the engine. We're going to take the valve, okay, and a trick that the Rebuilders Association has given me is you take a small piece of fuel line, okay, place it over the valve stem. This will simulate the valve being in the normal open position while the engine would be running. So all we have to do now is drop it down into the hole. We've got to adjust our dial indicator so it's resting on the edge of the valve. This sometimes can be kind of tedious, but with a little bit of patience, we can certainly get it. Okay. Now I'm going to again try to zoom in on this, so it might be a little bouncy, folks. So just bear with me. I want to get it so that you can see what I'm doing and see what the needle's doing. All right, now we should probably zero out the meter, but if we can do a quick subtraction, we can even count the number. We're going to push it all the way one way. You notice the needle hasn't moved. Okay, now we'll push it all the way the other way. All I'm going to do is push the valve one direction. And I have no movement. Oh, there it goes. Now wait a minute. It moved on me. getting deflection on the needle. The telescoping gauge with this variable tension unit is kind of a pain. Now you can see it. Okay, so now I push it all the way this way. All right, I got about 59 thousandths. I push it all the way the other way, I got about 63. Okay, so we got 4 thousandths. This will work if you're lucky enough to be working on a cast iron cylinder head. You can set up, of course, this on the cylinder head and just turn on the magnet, and it'll work just fine. But because a magnet will not work on aluminum, of course, let me just back out a little bit here. There we go. You can just set this up and turn on the magnet. It will be sucked solid to the cast iron head, and then you can set it up so you can measure the same thing. Not too useful on an aluminum head though. So you have to go back and use this crazy device. Okay, it can be tedious, can be aggravating. Just relax, a little bit of patience, it can be done. That's one of the reasons why, folks, I have you use a telescoping gauge and a mic. Okay, or a split ball gauge and a mic. All right. Now, that should conclude our measurement portion as it pertains to cylinder head repair.